All right, everybody, we finally made it to the last lesson of chapter 1. Woohoo! So we are on page 71. This is lesson 7, ratio and rate problems. We have 2 learning objectives that this lesson is going to look into. Learning objective H says I can use bar diagrams and equivalent fractions to solve ratio problems. And learning objective I can use lines and equations to solve rates. Now, basically, just to sum this lesson 7 up, you're going to have ratio and rate like story problems. And you're going to need to solve them. And essentially, you could use a diagram or a picture, or you could solve the ratio and rate problem with an equation. And you're going to have to decide, does it make more sense if I do a diagram, or does it make more sense to me if I do an equation? Or is this an easy problem for me to draw a quick diagram, or is it easier just for me to write out an equation? So I want you to make sure that you understand both ways, because sometimes it really is easier just to think of solving the problem with a diagram or picture, and sometimes the numbers are just easier to plug into an equation. So make sure that you're familiar with both ways and you understand both ways as we go through this lesson. We are going to turn to page 72 and start on there. So page 72, let's read this at the top. Solve ratio problems. You can use bar diagrams or equations with equivalent ratios to solve ratio and rate problems. So here's that idea of, are you going to use a diagram or are you going to use an equation? So we're going to look at a couple examples, and it's going to show us how to use a diagram and how to use an equation for each one. So if you look at example 1, it goes through, this is how to draw a diagram, this is how to set up an equation. Example 2, this is how to draw a diagram, this is how to set up an equation. So let's take a look at example 1. Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So if you set up a diagram, you could draw a bar diagram. Let's take a look at what the diagram is here. We have 150 students in the whole middle school, and we know that if they were split into 3 sections, 2 out of the 3 sections would prefer gel, because we're comparing it to Mrs. Mason's class where 2 out of 3 kids prefer gel. So if 2 out of 3 kids in her class prefer gel, then we're thinking 2 out of 3 in the whole school prefer gel. So 150 divides into 3 sections. 150 divided by 3 is 50. So 50, 50, 50. And 2 out of the 3 sections, assuming they prefer gel, would be 50 plus 50, which is 100 students. So you could say about 100 students in the middle school prefer gel toothpaste. Or you could set up an equation using equivalent fractions. So you turn our ratios into fractions. 2 out of 3 students prefer gel. So how many out of 150 students in the whole school would prefer gel? Now, 3 times 150, or 3 times 50 is 150. So you do the same thing to the numerator. 2 times 50 gets you that 100. So you get the same answer, 100 or 100, by either drawing a diagram or using equivalent fractions. All right, now we're going to take a look at example 2. The ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 text messages. How many text messages did his sister send? Okay, so the first thing that we're looking at here is a bar diagram, so drawing this out. Now, the ratio is 3 to 4. So if you make 3 sections for Lucas, 4 sections for his sister, that's a total of 4, 5, 6, 7 sections. Now, Lucas sent 18 text messages. So if you think his 3 sections, he sent a total of 18, and you divide 18 into 3 sections, 18 divided by 3 is 6. So if each section of all of our 7 sections here is 6, then you can add in 6 to his sister's 4 sections, and 4 times 6 is 24. So you could say the ratio 3 to 4 is just like 18 to 24. So his sister had 24 texts. Now, you could do an equation and you could set this up with equivalent fractions. So that's what it is up here. So this is the equation option. Lucas had 3. The ratio was 3 to 4. Lucas was 3, sister was 4. We know Lucas sent 18 texts. So how many texts did his sister send? 3 times what is 18? 3 times 6 is 18. You have to do that to the denominator. So 4 times 6 is 24. And there's our number 24 again, just like we got down here, 24. So you can set it up either way. Now, if you use the equation and you set up equivalent fractions, you need to make sure that you're putting the right number in the numerator and the denominator. So we had to put Lucas's numbers that we knew on top. It was his sister's on the bottom that we were trying to figure out. All right, we are now going to look at example A. Let's read it first and decide if maybe a diagram or an equation would be easier. And we could do both too. In a survey, 4 out of 5 people preferred creamy over chunky peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would prefer creamy peanut butter. Now, 4 out of 5, 120 total. This kind of reminds me of this situation right here. I think that it would not be difficult to draw this out in a diagram, and we could also try it in an equation. So let's do both. If we have 4 out of 5 people preferring peanut butter, how many, if there were 120 total, would prefer it? Well, let's see. 4 out of 5, so we need 5 sections. So I'm going to make this diagram here. 1, 2, 3, 4, 5. And the total people was what? 120? Okay, so if we do 120 and we divide 120 by 5, so I'm going to take my calculator, 120 divided by 5, that gives us 24 people in each section. So if there's 24 people in each section and we know 4 out of 5 people prefer creamy peanut butter, then we're looking at these 4 sections. So it's 4 24s. If you do 24 times 4, that's 96 people. Or you could set it up as an equation. So what do we know? We know 4 out of 5 people like the creamy peanut butter. And we could say that that equals something out of 120 people. So we're trying to figure out this number. So again, you have to say 5 times what is 120. To figure out what you multiply by 5 to get 120, you do that same thing again. 120 divided by 5. Oops, did that wrong. 120 divided by 5, that's your 24, remember? So it's 5 times 24 is 120. 4 times 24. Well, that's going to give you the 96, remember? So 4 times 24 is 96. So either way you do it, diagram or equation, you are going to have 96 people out of the total that are preferring creamy. Now let's look at example B. A survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant on the survey, how many people took the survey? Man, now I'm thinking about drawing a diagram for a minute, and I'm thinking, gosh, I would have to draw a lot. These numbers here that we'd have to draw sections of, 12 and 15 sections, is a lot. I think it's easier to just set up our equation. Let's see what we would do here. We have 12 out of 15 people preferring the restaurant over cooking at home. 400 people are selected out of total. How many people would prefer eating at a restaurant? So that 400 is our total again. So 15 times what is 400? So we can do that to the top too. Now, how do we figure that out again? If you do 400 divided by 15, it's going to give you that answer. 400 divided by 15. 26.66. Okay, so 400, just to double check that, divided by 15. Ooh, it's not a very happy number, is it? All right, well, what if we take that number and multiply by 15, just to make sure that made sense? Oh, see, okay, so look at 26.6666 times 15 gets you 399.9. See how that number is almost 400? So if we do 12 times 26.6, it's going to give us a number that's almost something. So watch, 12 times 26.6666, 319.999, that's almost 320. So you could say that 320 out of 400 people prefer eating at a restaurant over cooking at home. Okay, that one wasn't as nice because it didn't have nice round numbers, but it worked. Okay, now, this next part of the chapter is the same idea. Are you going to draw a diagram? But actually, the diagram is going to be number lines. So to solve these rate problems, we're going to choose, do we want to draw a number line, or do we want to write out an equation again to solve the problem? So we're going to look at example 3. All right, here we go. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So it's saying to draw a number line, a double number line, meaning you have one part of your rate at the bottom and the other numbers of your rate at the top. So there's the double. There are numbers on the top and the bottom. So here we go. We have on the bottom of the number line numbers that represent gallons of gas. So 0, 1, 2, 3, 4, 5, 6 is what we want to find out, right? We're trying to find out how many they can drive on 6 gallons of gas. Okay, now at the top, we know that they drove 105 miles on 4 gallons of gas. So this is what we know here. They drove for 4 miles 105 miles on 4 gallons of gas. So if we could find out this unit rate, how much did they drive? How many miles did they drive on 1 gallon of gas? Then we could figure out for each unit and add up to 6 or multiply. So that's why they did this here. 105 divided by 4 is going to give us this unit rate, 26.25. Now, 26.25, it's kind of like our bar diagram. This is 26.25. This is 26.25. This is 26.25. 26.25. 26.25. 26.25. If you add up all those 26.25s, or if you do 26.25 times 6 sections, 26.25 times 6 is 157.5. So that right there is your answer. Now, if you set this up like an equation, then you would get what they're going to show us on the next page when you find a unit rate and set up an equation. So let's try to set up a double number line and solve this problem right here with ice cream, just like they did up here with the gallons of gas. There are 810 calories in 3 scoops of vanilla ice cream. So how many calories are there in 7 scoops of vanilla ice cream? All right, let's check this out here. Let's make our double number line. I'm going to make it right down here. All right, let's at the bottom put our smaller numbers like they did. So we've got to go up to 7 scoops of ice cream. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, we're trying to find out how many calories. So this is scoops and this is calories. How many calories are in 7 scoops of ice cream? We know that in 3 scoops of ice cream, there are 810 calories. And there are going to be a lot of calories in 7 scoops. So how many calories are in 1 scoop? If we can get this unit rate, if we can do 810 divided by 3, 810 divided by 3, that'll give us our unit rate. How many is in 1 scoop? So I'm going to do that. 810 divided by 3. Ooh, it's a nice rounded off number. 270. So 270 is our unit rate. Now, 270, 270, 270, 270. If you add that up, you have 7 270s. That'll give us our answer here. So 270 times 7. Let's do that. 270 times 7. 1,890 calories. So 1,890 calories is our answer. Wow. Now, maybe you don't like these number lines. So let's take a look and see how we can write out an equation. That's what we're going to look at on the other side. I'm just going to show you a little preview on this one on what an equation might look like. So if we set up our ratios and we know that there are 810 calories in 3 scoops of ice cream, how many calories are in 7 scoops of ice cream? That's a little tricky because it's going to give us not a rounded number because we don't know 3 times what is 7. You'd have to do the same thing to the top, 810 times whatever this number is to the top. To find out this number, you do 7 divided by 3. 7 divided by 3. See that? It's not a nice whole number again, 2.33333. So if we did that here, let's see if we get something that would round to this. 810 times 2.3333. See, look at that. 1,889 is almost 1,890, which still gives us that same answer as we got down here setting up an equation. Okay, so what do you like more so far, diagrams or equations? Sometimes it depends on the question. Let's take a look at the last example. This is page 74. All right, last example. Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? At what rate did he drive his motorcycle? Now, if this was the draw the double number line again, you could draw that out. You could draw a number line and you could have, 0, 1, 2, 3, 4, 5 hours. 5. And at the top, we know that in 3 hours, he drove 120 miles. How many miles did he drive in 1? 120 divided by 3. Let's do that. 120 divided by 3. 40. So in 1 mile, he could do 40. Or in 1 hour, he could do 40 miles. See, that's what happens when you don't label this. This is hour, this is miles. So if he could drive 40 miles in 1, how many could he drive in 5? That's what we're trying to figure out. So 5 miles times 40. 40 times 5. 200. Let's see if they get their same answer when they set up this equation for us. Okay, so they set up the equation to find a unit rate. 120 miles in 3 hours. Remember, divide by the denominator 3 gives you the unit rate. So when you do 120 divided by 3, just like we did right here, you get 40 miles in 1 hour. 120 and 3, 40 miles in 1. Now, if you know the unit rate, 40 miles per hour, how many did he drive in 5 hours? 4 times 40 is 200. There it is. You can also set up this equation like this. There's so many options, you guys. If we know there are 120 miles in 3 hours, this is miles, this is hours, that would equal how many miles in 5 hours? 3 times what is 5? 120 times the same thing will give us our answer. So 3 times what is 5? We would have to do 5 divided by 3 to find that. It's not going to be a pretty number. 5 divided by 3, 1.66666. All right, so let's do that to the numerator too. 120 times 1.66666. Look at that, 199.9. That's almost 200. So again, it gives you your same answer. 200, 200, 200. Draw the line, find the unit rate in an equation, or you could set up that equivalent fraction just like we did on the other page. Let's try this one. All right, last one, and then we'll do guided practice. While resting, a human takes in about 5 liters of air in 30 seconds. At this rate, how many liters of air does he take in during 150 seconds? All right, what do you want to do? If we draw a line, we would have to draw, we'd have to draw 30 seconds, 100. This one I don't know, guys, about the line. Let's set up an equation, because look at how much we're going to have to draw there. Those numbers are huge, because we don't know how many liters we're trying to find out how many liters of air he takes in. What if we set up an equation? He can do 5 liters in 30 seconds. How many liters can he do in 150 seconds? Let's set up the equation. We know that a human takes in 5 liters of air in 30 seconds. So 5 liters of air, this is our ratio that we're going to set up this fraction with that ratio, 30 seconds. We're trying to figure out how many liters in 150 seconds. So how many liters is that in 150 seconds? So we need to figure out 30 times what is 150. Now how do we do that again? With our calculator, if we do 150 divided by 30, that'll give us this number right here, 150 divided by 30. Now the reason why that works, by the way, is because multiplication and division are the opposites of each other. So look at this, 30 times 5 is going to give us 150. I'll even show you. 5 times 30 equals 150. Okay, so now what we do to the denominator, we have to do to the numerator. So 5 times 5 is going to give us our answer. And we know 5 times 5, that's 25 liters. So 5 liters in 30 seconds is equivalent to 25 liters in 150 seconds. 25 is our answer. And I really think that setting up that equivalent fraction equation is the easiest one there. Due to the big numbers we'd have to be writing in a diagram. But if you wanted to draw out the diagram, you could do that too. All right, the lesson is done. Now, next thing will be guided practice. Okay, so we are on page 74, chapter 1, lesson 7, and we're going to do the guided practice now. So we are trying to figure out what works best, a diagram or an equation. Some of these, one works better than the other. Some of these you really could do any. So I am going to show you different ways just in case you chose something different. Go ahead and look at the first one. Out of 30 students surveyed, 17 have a dog. Based on these results, predict how many of 300 students in the school have a dog. Now, go ahead and pause this, either draw out a diagram or do the equation. Honestly though, you guys, with these numbers here, you might not want to draw out the diagram. That would be drawing like 30 little boxes in that bar diagram. But Go ahead, pause it, solve the equation, play it, and see if we got the same answer. If you're totally stuck, start playing it and see how I set it up, and then pause it. All right, go ahead. Okay, so on this one, honestly, drawing that picture is crazy. I would definitely set up the equation due to the numbers. So we know that 17 out of 30 kids have a dog. So I would say 17 out of 30 have a dog. So how many out of 300 have a dog? Well, we're trying to figure out this number. 30 times what is 300? This one's kind of, we don't even need to calculate because we know 30 times 10 is 300. So 17 times 10 is 170. So there's your answer right there. 170 students. All right, let's go on to number 2 in the guided practice. If 1 out of 12 students at a school share a locker, how many share a locker in a school with 456 students? Now, maybe you want to draw this one out, or maybe you want to set up an equation. I'm going to let you choose. Go ahead, pause it, do number 2, and then play it and see how I did it. Okay, so you know what? I'll go ahead and draw a diagram for this one because we have 1 out of 12 students. So I'll draw 12 boxes. Whoa, that's really scary. Oh my gosh, that's horrible. Okay, I'll put it down here. So if I've got my bar diagram here and I need 12 sections, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, I have 12 sections. This whole thing as a total is supposed to be 456 students. And 1 out of those 12 sections is what I'm looking for. So what if I just divide 456 by 12? 456 divided by 12, 38. So there's my answer right there. 38 students. Now if I set up an equation, we know 1 out of 12 students, and we're trying to figure out how many out of 456. So 12 times what is 456? Well, remember, you have to do 456 divided by 12 to get that. When we did that, it was 38. So 1 times 38 gets you 38. So either way, the answer is 38 students. Okay, we're going to do this last one. So we're only looking at 1, 2, and 3. Sabrina jogged 2 miles in 30 minutes. At this rate, how far would she jog in 90 minutes? At what rate did she jog each hour? Ooh, they're asking 2 things here. So, how far would she jog in 90 minutes, and how far would she jog each hour? If you can figure out that unit rate first, what did she jog each hour, then it'd be easy to find out how she jogged in 90 minutes. So, that's why it says examples 3 and 4, because you're going to try to find out the unit rate first. You might want to draw one of those number lines, or maybe set up an equation. All right, go ahead, pause it, do what you want to do, and then I will show you what I did when you push play. We can compare. Okay, so what do we want to do here first? Do we want to set up a double number line and then set up an equation and then see what happens? We have to find the unit rate first, and then we have to see how far she would jog in 90 minutes. So I'm going to set up a double number line, and since we're not using this area for this question, I will set it up right here. Okay, so if I'm setting up a number line, see if I can draw this a little better than the last one. What do we have? We have 2 miles in 30 minutes. So we know, gosh, we don't really know how many of these, this is 0, 1, 2. If in 2 miles she went, remember I better do this so I don't lose track, 2 miles, 30 minutes. All right, in 2 miles, she jogged 2 miles in 30 minutes. So how many would she jog in 90 minutes? Well, look, 30 divided by 2, she must be jogging 15 minutes. Look at that. She went 1 mile in 15 minutes. I got that unit rate because what I did was 30 divided by 2. So each of these two sections is like 15, 15. So in 15 minutes, she goes 1 mile. At what rate did she jog each hour? Oh, that's going to be 60 minutes, isn't it? Yikes. So that's not even the unit rate I was thinking of. Okay. Wow, you guys, this is interesting. It's getting better by the minute. All right, so each of these sections is 15. We're trying to get up to 90 minutes. So 30 plus 15 more, that's going to give us 45. Plus 15 more, 60. Hey, that's a number that we need to know. Because how much did she jog each hour? That's 1 hour. That would be 4 miles. So at rate, oh my gosh, I did it again. At what rate did she jog each hour? That is the unit rate. So she was going in an hour, in 60 minutes, she could jog 4 miles. So in 1 hour, this is 1 hour, she jogged 4 miles. So at what rate did she jog each hour? 4 miles per hour. Okay, the other one was, how far did she jog in 90 minutes? So 60, we need to add another 15 minutes there. So that would be 75. Another 15 minutes onto 75, that's our 90. So 90 minutes, so 4, 5, 6. So she jogged 6 miles in 90 minutes. Man, so you could definitely get your answer from a double bar line for this one. But how could we get our answer with equations? So let's take a look at that. Maybe you used an equation. I'm going to draw some equations down here. Well, here's one equation. We know that we need to find a unit rate because we're going to have to figure out how much she jogged in an hour, 60 minutes, and how much she jogged in 90 minutes. So to get a unit rate, let's set this up. 30 minutes, 2 miles. 30 minutes, 2 miles. Unit rate, divide by the denominator. So we can get 1 in the denominator. Divide by 2. 30 divided by 2 is 15 minutes. So she can do 1 mile in 15 minutes. So if she can do 1 mile in 15 minutes, how many can she do in 60 minutes and in 90 minutes? Now last time we did the 60-minute one first, so let's do that again. So if you have 15 minutes, 1 mile, that equals, sorry, this fold is messing me up. How many in 60 minutes, because that's an hour. So 15 times what is 60? So we can do that to the denominator too. 15 times 4 is 60. And if you're not sure about that, if you do 60 divided by 15, that gets you 4. Yay, I was right. So 1 times 4 is 4. 4 miles and 60 minutes. We got that same answer here for the 60 minutes. Now we have to set up this unit rate, 15 minutes in 1 mile, and figure out the 90. So if we have, where can I write that? Well, right here. 15 minutes, 1 mile equals 90 minutes. How many miles? So let's see, 15 times what is 90? 2 15s equals 30, 30, 60, 90. So I'm thinking it's times 6. Let's check. 90 divided by 15. 90 divided by 15 is 6. So 15 times 6 is 90. 1 times 6 is 6. There's that answer, 6 miles in 90 minutes. So whether you draw it out or whether you do equations, you can end up with the same answer. Okay, for the independent practice, we're on page 75. I'm asking you to do 3 of these problems. Now, when you do these 3 problems, you can choose if you want to draw the diagram, the number line, if you want to draw some kind of diagram, or if you want to set up an equation. It's your choice. You don't have to do both. Okay, so just number 1, 2, and 4. Go ahead and stop the video and do your homework.